Good morning, ladies and gentlemen. Welcome back to Math 1800 Pre-Calculus series from Wayne State University, focusing on particularly right now logarithms. Okay, this is Resh Mahaber signing on. I just wanted to give you a quick 20-minute video on how we deal with logarithms, and this is part of a bigger topic of the last two videos in this series. I would tell you, and I know I have them listed by section, which is 401, 4.2, and this one is 4.3 continued, kinda. I would tell you to look at all three of these in sequence just so you get a more solidified understanding of how logarithms work, because it is part of a bigger topic. So looking at all three videos will make your life way more the picture well-rounded versus not. So let me give you a quick overview, hopefully in the next 2 minutes, because I'm not trying to take up much of the video with this, because we have a lot to talk about with logarithms. Okay, so what was the purpose behind logarithms? I started the last video by talking about the order of operations, which was this. Okay, parentheses, exponents, multiplication, and addition. Then we talked about how exponents has two inverses, roots and logarithms, and then we talked about their purpose. So let's say you had a problem and it was 2 to the third equals x. We would use exponents to solve this guy, right? This is exponents. If we had to do a log problem, though, right, well, where would we even need logarithms here? Well, or roots. Well, let's go back, and this is where you learned probably in the last 3 or 4 or 5 videos that if the base is missing, and you know what the answer is, you would use a root to solve this, right? And then finally, branching off from that, what's the one thing we don't know how to solve for is if the exponent was missing. So note, this is an exponential problem. Okay, it's an exponential problem. To solve an exponential problem, we need logs, because logs undo exponentials, and that's the big thing. So this is like, I'm write that in red and put bubbles in it and all this other good stuff, because it is the big piece of what we're talking about. Logs undo exponents. Okay, so there's a connection between exponentials, which look like this, which I'll generalize to say base, exponent, and answer. But I want you to keep in mind the context of what we're talking about here is we don't know what this exponent is. So when we're trying to solve for it, ideally we want to get the exponent out. So how do we do that? Well, in the previous class, which was Math 1050, which is basically intermediate algebra, we talked about just a conversion from this into exponential form. Exponential form into log form. So this is exponential form, right? Exponential. But there's an equivalent log form, and how we write it is log. The base is written as a subscript. The answer is written here because we know what the answer is. Boom, and we know what the base is. What we don't know is the exponent. The exponent is the thing we're trying to solve for. So that's why logarithms are so important, because it is our only tool to break into exponents. And that is a gigantic piece of this puzzle, is we need to use it to break into exponents. Without it, we're screwed. Okay, so we use roots, and what would we do if we had a root? We would cube root both sides, right? Meaning that it's an operation. An exponent, we cube two sides if we wanted to, right? A log, well, guess what we do? We log sides as well, okay? So we're going to talk more and more about this as time goes on. And we talked about evaluating logs, but I want to take a second, and we're going to go over everything that has to deal with logs today. Maybe we'll talk about that in a quick example right now, actually. So let's say I said find the exact value. And I always say chapter 4 for 1800 is a whirlwind. I'm going to leave this exposed because this is what we still need. Is a whirlwind because it feels like everything is the same. It's just talking about it in different ways, okay? So I'm going to try to make this as fluid as possible. So let's say I said evaluate log base 8 of 32. Okay, so what is the answer? And yes, this is an exact guy. So how do we think about this? Okay, now if this is an easy guy, let's say this one, let's not make the base 8 right now, let's make it 2. Okay, then you're looking for some answer. I'm going to put a box here. This is the way we would do it in the algebra class. And we'll say, okay, base is really that base, right? So that's the base here, so it's 2. The exponent is the answer. So this box unknown, would be the exponent we're looking for. And the answer, well, it's sitting right there in front of your face, which is 32. So now, what do? Well, you just start multiplying 2's together, and hopefully you hit goal, which you do in this case. The answer ends up being 5. Easy, right? But then when you have trickiness, like log base 8 of 32, now you need to use some skills here, okay? And what do I mean? It's the same thing. Don't know what the answer is. And I'm sorry, I feel like I'm rushing a little bit, just talking really, really fast. I just want to make sure we have enough time to squeeze it all in, because this topic, or maybe we'll just make the video a little longer. We'll make it like 30 minutes. I know I try to keep them under 20, but this one, it really is a broader topic. Okay, so this is the transformed version from log form into exponential form. Okay, so if, whoops, erase. Okay, so if we have to look at this, 8 to what exponent is 32? Boom. So now you got to start thinking to yourself, and this is going to be the big think bubble here, because this all needs to happen in your brain, considering now you guys are going to be the guys who go to calculus. So this is your brain. And I don't know if you guys remember the commercial where like, this is your brain on drugs, and they'd break an egg into the, no? All right, never mind. All right, so anyhow, so this is what you should be thinking. 8, right? He is a base 2 guy. What do I mean by a base 2 guy? He's 2 to the third, right? I need 3 of those. And also, 32 is a base 2 guy, right? I know 2 to the third is 8, and I know 2 to the fifth is 32. So the connecting base is 2. That is the fact of the day, okay? So now you combine that information with this, that you know that fractional exponents are really roots. So if you combine these two facts, then this is when stuff gets very, very exciting. So what I'm getting ready to say right now is probably going to be the most important piece of this entire lecture, okay? To get this 8 down to its generating base of 2, I first need to cube root it. Okay, and I know people give equations on how to solve these from like things in the past, but it takes a thought process out of it. You want to think about these, and that's the most important part. Okay, so the cube root of what is going to get this 8 down to 2? Yes, you named it. It is definitely the cube root. The root of what? The cube root. I gave you the answer already. I always do that. Okay, so if you cube rooted 8, you get 2. Now, what do you need to raise 2 to? So right now we're stuck at 2. If we put that 3 in there, what do you need to raise 2 to? Well, you need to raise 2 to the 5th power. And that will get you 32. Now, this is a question mark here. We don't know that for sure. Now, here's your check. You should be able to do this in your head, but if you can't, not to fret. You should be able to go through the work. That's that, that's that, that's this to that, which is 32. Bingo. And the idea is all of this work that's happening over here, you're not writing this. This is all supposed to be happening in your brain. So people always say, well, Resh, I could find an equation to write that would do the same thing. Part of the issue with education in general and learning is, yes, you can find an equation to write and solve anything, right? But just imagine if you had to show all the mathematics from the beginning of when you started learning math all the way until now. You would not have enough time to finish one problem on any quiz or exam. Time is part of the game. No, deadlines are part of life. So in the end of the day, if you're not constantly looking for not just ways of getting answers, but more efficient ways of getting answers, you're never going to be able to finish any race that you start with mathematics, or for anything else for that matter, okay? You won't be able to hold on a job, more or less, okay? So let's really look into how we become more efficient. So this is how we'd become more efficient. Okay, let's do another one. Now that one was a little bit more difficult because it required stuff. Let's really combine some stuff and make it look nasty looking. Here's another good one. Example, log, here's an example. I'm going to put this one in black just to alternate the color. Log base 8. We'll keep the same base. This time I'm going to make this 1 over 32. Now we should be able to play the same game, right? I want you to do this in your brain. The base is 32. The base is 8, sorry. I'm getting ahead of myself like I always do. The base is 8. The exponent, we don't know, box unknown, is 1 over 32. And we're going to play the same game. So check this out. You already know the connecting base between 8 and 32 is 2. So we have to take the cube root to get 8 down to 2. Beautiful. But to get it to 32, we'd have to raise this to the 5th power. You notice this is exactly the same like the last one. But there's a problem. This is 1 over. So what exponential law do you know that makes things 1 over? You dang on right. It's got to be negative. See how easy that is? So note, we're using all the laws of exponents that we learned. Those 7 laws of exponents. No, exponent raised to an exponent. We multiply to 2. A to the n times a to the m. We add the 2 exponents together, right? All those laws, we're basically using them just backwards. Okay, so we really need to keep hold of those laws to really understand what's going on with logarithms, and that's very, very important. Let me give you one that's a little cheekier looking, okay, and that's this one, okay. And actually, example, log base 2 of I don't know, I think 2 is too easy. How about we put a 32 here? And we make this 1 square root of 2. Ooh, scary, scary. All right, not to fret, guys. This one's not too bad. It is a little bit advanced, but advanced is always a question of how good you are, right? What I mean by that is things are advanced when you're just learning, and then it becomes normal. And that's what the whole point is, that this isn't really advanced, it's just normal. All right, so let's play the same game. And I know I'm using base 2, but I could change to base 3, right? 3, 27, 9, 81, 243. These are all base 3 exponents. Base 4, same thing. 4, 16, 64, 256, right? So if you don't know your bases, then it's going to be just hard to recognize, and you have to start playing with the numbers. And that's when you really start burning up time, is when you have to play with the numbers. So here we go. 32 and 2. Okay, notice I'm just looking at the numbers that have some sort of connection. And that's the whole idea, is you got to find a connection between 32 and 2. Okay, so 32 and 2 are base 2 guys, right? 2 is the first power is 2, and 32 is 2 to the 5th. Okay, so we know this. So first things first, let me break 32 down to its generating base of 2, which is 5. I'm going to take the 5th root of it to get it down to 2. Done, right? Now, how the heck do I get 2 to be this? The plot thickens. You see how it gets a little harder, because this square root itself is an exponent. You see that? So what do we really do? What do we really do to actually help with these harder guys? Okay, these are guys we can kind of common sense our way through, but you notice this is really a pain in the neck to really deal with. Good news. Here's the good news. So everybody, this is where this right here was common sense. Let's talk about something you've seen before, okay? And there's also, the same way we have laws of exponents, we have, and I'm going to come back to these same 4 examples, and we're going to redo them again and get the answer. But for this pain in the neck guy, we need to have some cooler tricks to use up our sleeve. So let's try to use some cooler tricks. All right. So, and once again, here are your laws of logarithms. And after we do that, then we'll finally get into graphing. I can't spell today again. What is going on with me? All right. So here's something, and I'm gonna go through. I'm gonna rework each one of these examples so you can actually see where the laws come from. Okay. So check this out. I can rewrite, and maybe this is how I'll do it. I'm gonna take these 2 and use these 2 as my guys. Would everybody agree that I could rewrite 32 as 2 to the 5th power? Now here's where the one that's going to be really, maybe I'll use a bit more basic example. Whoa, what happened? Minitab decided it wanted to pop up. Oh my God, everything's disappearing. All right, so log base 2, and let's say I said 16, 2 to the 4th power, 16, right? But notice something. All right, so everybody see that? I'm going to get rid of the 16. You would agree that I can rewrite that as 2 to the 4th. All right, so now I want you to look at these 2. This is like the biggest piece, and I'm going to connect it to the whole beginning of the conversation. Okay, so notice how they look. Okay, I'm going to zoom out a little bit so we can actually see up here and down here. So here's law number 1. Now, this is a green light. If you have a log, the base is some number, and then the argument is that number raised to an exponent. I'm going to call it x. If it wants to erase. Okay, it doesn't want to erase, so I'll just call it x. What is the answer going to be? Absolutely. See that 5? See that? It seems like the log undid this thing that had the same base. So, but I want to draw your attention to something. This is an exponential. didn't we start the conversation with logs undo exponentials? So it just makes sense that because this base is the same as that base, they would undo each other and just leave you with the exponent. So done and done, this is just x. Done and done. That's law number one. You got to know brass tacks, the basics of logarithms. And then obviously I'll put not law number 0, but the basic understanding. Basic understanding is how to convert these. The base, you have the exponent, it's equal to the answer, and this is the same as base, sorry guys, log base. I've been trying to cut coffee out of my diet. Do you know that is the hardest thing I've had to do? Like, my brain is just not operating correctly. It is the worst. Okay, so this is the basic understanding, but then here are the laws that come with that basic understanding. So you need to have the conversion in your head, but these are the laws after you got the conversions. Okay, so here's the idea. If you log an equation that has the same base, it should undo each other and give you this. Likewise, just to keep the video a little shorter since we're already 16 minutes in and I want to get to some examples, we talked about logs undoing exponentials, and exponentials undoing logs. So this one looks a little freaky and freaks everybody out, but not to fret. Okay, so everybody watch. If you have a log of any base rate of something, right? Some number, some variable, some whatever, right? If you base A it, the same way the log undid the exponential undoes logs, which gives me just regular old x. These are the two guys that you need to be good with. Now, I know this is not expressed up there with an example, so let me give you a couple good ones so you guys get why this works. Exponential example. Okay, how about this? 2 log base 2 of, you can't do that one, of 8. So we followed order of operations, and I said evaluate this. What happens? Well, what is this equal to? Well, 2 to what power is 8? 3. That means this is 2 to the 3rd power, which is 8, right? So check this out. This thing gave you 3. This thing sent it back to 8. So this thing in the end is equal to 8. Doesn't that make perfect sense, right? So in the end of the day, the log undoes an exponential and the exponential undoes a log when the bases, and also the emphasis here is the bases are the same. Is everybody cool? And I just want to point something out to everybody. And you'll notice that this is going to become a big focus on the conversation. A lot of these properties work because the coefficient in front of the log is 1. Okay? So I want to make sure I emphasize on that because eventually we're going to start doing stuff with these and the coefficients will not be 1. We're going to have to be good with it. Okay. All right. So now this brings us to why we actually need these. Because if you have something that's ugly looking, here's ugly looking for you. I'll give you another example. We don't use these laws for basic stuff. Well, yeah, we do use it for stuff like this because it's nice to know that it undoes it. But if you have something that's completely hideous, like 3 log base 3 of square root of 7, it's nice to know the answer is just square root of 7 without even doing any work because the two bases undo each other. Done and done. Okay, so those are the first 2 big laws of logarithms. And as logs undo exponentials, and exponentials undo logs. All right, so now that we are about 18 minutes in, okay, we're just working with logarithms, and this is how they work. I want to talk about this one again. See how ugly that guy was? Let's come down here and do some more work. Okay, so before we get to rocking and rolling, remember, the pretext of this conversation is that these bases are the same. So here's a question. What if the bases are not the same? Okay, so third law of logarithms. This is a big one. These guys should look familiar to you as you guys have already taken the course before this. If you don't, then go look at the other videos that have to do with logarithms from the intermediate algebra course, and it would make much, much more sense. There are 3 laws, okay? Okay, so if you have a log and the base is A, but the other base of this guy does not match. Now before, if this was an A, these two would undo each other and just leave you Y. But the whole pretense is the base must be the same. So what if the bases aren't the same? Well, let's talk about, before we talk about that guy, there are 2, maybe I should talk about the other one first. I'm sorry guys, I'm so flustered. This whole coffee thing is killing me. All right, so if you have multiplication in here of two things, this is log base a of x plus log base a of y. Now, I'm not going to go into detail why this is. If you want to know, come send me an email or come to office hours, and I'll go through the entire proof with you. But here's the idea. You know the answer to this is an exponent. The answer to this is an exponent. When you're adding exponents and the bases are the same, what are you doing to the original problems? Does that sound familiar? A to the n plus m, adding exponents. What are you doing to the original problems? So really, these are just your laws of exponents written in logarithmic form. Moral of the story. But you know, if you want a more rigorous proof than that, then come see me and I'll be more than happy to. So that's the first one. And the second one, it comes from the other law of exponents as well, that if you're dividing the two problems and they have the same base, then what you're really doing is subtracting the exponents, which in this case, since the exponents are the logarithms, you'll be subtracting the logarithms. Yeah, this should all be ringing bells. And then there's this very last one, which is log base a of x to the y, which is the exact same as y log base a of x. Okay, so these are the three laws of logarithms. Again, if you want to know why, come see me. I'll be more than happy to talk about it. Now, once again, here's something I'm going to emphasize with you. On the first two, and this is the reason why I wanted to talk about the first two ones. So notice the coefficients on all the logarithms are 1. So to even use these, the logarithms must be 1. So what if the log is not 1? Okay, to even use these, what if the log is not 1? Then what needs to happen is, so let's say the log is 2. You would have to throw this guy back in. We used to call this a parachute property. You throw it back in to make it 1 so you can unlock the rest of these. Okay, so I know this sounds really weird, but this is the 5 laws of logarithms that you are going to need to know to solve anything. All right, so now let's take a look at this guy that was a pain in the neck finally. Okay, so once again, the first 3, common sense, you're using the basic understanding. Good news, if you can get the bases to match, then they undo each other. But what if the bases don't match or it's just too complicated to see? Then you got to use some muscle. So now let's look at the muscle. Okay, here's an example for you. And I'm just going to write that guy back down here. Log base 32 of 1 over the square root of 2. All right, it is a pain in the neck. But check this out. If you notice, we don't have any laws of logarithms that have roots in it. We do have one that has an exponent in it, and I do know how to write roots as exponents. So I'm going to rewrite this as log base 32 of 2 to the negative 1/2. You guys see what I did there? Because that's 1/2 and it's negative 1/2. Note the bases are the same. All right, so a lot of you guys are already seeing the green light, so let me help you. What are we going to do with this? Using the 5th law, we're going to throw it out and it's going to be the coefficient. Now note, everyone thinks these laws are one directional. Equal signs mean goes both ways. So you might need to throw it back in sometimes, and sometimes you might need to take it out. In this case, I needed to take it out because I was trying to simplify this guy down, and the negative 1/2 was just complicating my life. All right, so now we're here. Life is warm and fuzzy inside. Now, can we do this? Now we need to rely on our basic understanding, the one that we talked about before. 32 to what exponent is 2? Here's my think bubble. What's the connecting base? The connecting base is definitely 2. This is 2 to the 5th power. This is just 2 to the 1st power. So that means I need to take the 5th root of 32 to get it down to 2 and then raise it to the 1st power to get 2. So it's 1/5. So this piece right here is just 1/5. So you're going to use a combination of your common sense understanding of logarithms along with those 5 laws. Isn't that beautiful? Which gives you negative 1/10, which is the answer to this big blob. Absolutely beautiful. Okay, so I think this is a great stopping place. And what I'll do is in the next video, I will actually start right here and continue on recalling some of this basic stuff so I don't have to rewrite it. And then we'll start talking about the working with logarithms part, because we didn't even talk about graphing yet. You know, it's a giant concept. We were just talking about working with them, and we might do 1 or 2 more. Okay, look, we're doing one more example. I've made an executive decision. Okay, we're doing one more example. Okay, what if you got another guy that looks like this? Okay, so this is where if you have a log and there's an exponential and it's all freaky looking and you're trying to figure out what to do with it, right? It's just really ugly, 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 ugly. Well, you got to use some of those log properties because the bases didn't match, and that was the point in fact here. So let me give you two problems. I'm going to give you two problems that we're going to work with here. Here's the first one. The first one is a guy that looks like this. Oops, already had an example there. E to the 4 ln of 3. That's right, ln and e. Do not freak yourself out. Okay, and the other one is this guy. 27 to the log base 3 of 2. Okay, so these two, don't forget laws 1 and 2. Now, these two should be screaming at you, simplify me, simplify me. Why is it should be screaming at you that? Because e to the ln of whatever the heck is there is going to be whatever the heck is there. But why? Because e to the ln is really just log base e of whatever's there. Right? So these would undo each other. The coefficient's 1. It's ready. It's ready. It'll just be that question mark, whatever's there. But here's the problem, and this is what I was telling you earlier, that things get complicated when the coefficients is not 1. Right? It's a coefficient of 4. So what do I need to do with this? I need to throw it back in to the logarithm. And this way, what will happen is e ln, and what happens in here is 3 to the 4th power. Okay, now it's screaming at you. E and ln want to undo each other immediately right now, which it can, but I always say simplify first, just because you want to make sure things are clear. Now, obviously, e and ln, now that the coefficient's 1, will undo each other and just give you straight up 81. Life is good. It's not that hard. You just got to play with it. Okay, now this is when the base was that and the other base was that, but there's this lingering coefficient. Okay, look at this guy. And once again, if you recall your properties, what does this look like? It looks a lot like this guy, right? Where the base raised to a log. The log is now in your exponent. So, but remember, the bases have to be the same. Let's go back down to this guy, which is somewhere. Ooh, I zoomed in a lot, didn't I? Which is right here. Notice the base here is 27. The other base is 3. So you're looking at this like, man, this is ugly looking. Now note, you cannot touch this base here. You cannot touch it. Okay, a log that has a set base, you're really not going to be able to play with that. But you could play with this if you knew what you were doing. Okay, so I'm going to show you how to know what you're doing. So I want you to look at 27 and 3. What's the base they have in common? And you notice this is always going to be an ongoing theme as well. What's the base that they have in common? Well, 27 is 3 cubed. So I'm just going to rewrite this 27 as 3 to the 3rd power. All right, now let's go back to your intermediate algebra skills. When you have an exponent, which is this 3, raised to another exponent, which is this log-based nonsense, what do you end up with? 3, because you multiply the two together. You get 3 times log base 3 of 2. Okay, now I'm going to make this other 3 here, the coefficient, red, because there's a lot of 3's on here, and this is really the only one I've been doing stuff. Now, if you notice, this base of 3 and the other base of 3, how do they match? You should be joyous, because they're saying to you now, finally, undo me, undo me. But they can't undo each other because of this dang coefficient of 3. It has to be coefficient of 1. So what's the solution? Parachute it in like the last one. So this thing needs to get thrown into the argument, and what ends up happening is you get 3 log base 3. What's in here? Well, I'll write it all out for you. 2 to the, I'm writing it in red so you see it, and there's my 3. So notice it was a rewrite which made this an exponent. The exponent now, because of the laws of exponents, you multiply the two together, became the coefficient on this log, which to get rid of it, because it complicated things, we had to parachute it in, which gives us this, which now finally simplifies down to, drum roll please, that. And then, because this and this undo each other because of the second law of logarithms, we end up getting this. Easy peasy lemon squeezy. Okay, look, it's 29 minutes. I might as well go for one more example. What do you guys think? I feel like that's the right thing to do. If you guys don't like it, then pause the video, go get you a drink of water, use the bathroom, and then we'll talk about it. Okay, I lied. 2 more examples. Yeah, I lied. 2 more examples. Here's one that came off of an old final exam. E to the 4 ln of 2. And I feel like they put problems like this on the final exam to see whether or not you're memorizing or if you're conceptualizing. Because you notice there's a lot of just like little things. There's a lot of little things of like subtraction implies division and division implies subtraction, but that's not what this is. So you really have to know the context of what you're doing. Okay, I stick to the truest context of the world, which is the order of operations, meaning that I see things like the e and the ln want to undo each other, and this ln and this e want to undo each other, but I always stick with this idea of I want to make sure that I understand what the properties are doing. So note, parachuting only applies to logarithms. It does not apply to exponentials. So for example, if there was a 2 here, don't you dare think you could take this 2 and shove it up there. That is 2 times this. No bueno. That's an exponential. No good. Okay? Now, because this is 4 times a log, logs parachute all day. Logs, you could throw that into the argument and what you need because this is log base e. So this right here will give you e ln of 2 to the 4th power. This subtraction sign is still here, and this is still 3 times. Now look, you could parachute this in, couldn't you? You could. Actually, as a matter of fact, I think we should probably do this problem twice, but I don't know if we'll have time for that. I could take this and throw this in. Why? Once again, that's a log, right? But then it's an exponent to an exponent, which is perfectly fine. And as a matter of fact, let me do that. This would be this raised to the 3rd power, right? This ends up becoming e to the ln of 16, right? 2 to the 4th power of 16, not 8, minus ln of e to the 12th. Okay, now some people are saying, oh, division, it's a logarithm. No, guys, do not get twisted. Let me recall to you the property that's up there. If you have log base a of x divided by y, then that's where the subtraction sign comes into play, right? But I want you to pay attention here. These are logs. This is an exponential. This guy's a log. It's not going to happen. So that's garbage if you're trying to use this with this. It's an exponential, so context is key. So what are we doing here? We're just simplifying. E and ln is going to undo each other because they have the same base at 16. The coefficients are 1. This will undo each other again. This gives you 12. The answer is just 4. Easy, guys. It's so easy. You just got to take your time with it. All right. Let me show you an example of where the minus sign really would come into play with a log. Simplify this guy. ln of 1 over the square root of e to the 3rd. Okay. Now, there are many ways of tackling this. As a matter of fact, I'm not done with this example. Let's talk about this sidebar. You didn't even have to parachute this in, right? If you just looked at this as what it was, face value, ln of e to the 4th, isn't this already ready to undo each other? Correct. The coefficient is 3, not 1. So why does it undo each other? The coefficient of 1 comes into play if you're going to use the other properties, which where you're combining logs. We're not combining a log, we're just simplifying. This is going to undo each other, give you straight up 4. This will give you 3, which is 12. Isn't that what we got? Okay, so guys, please understand there are multiple ways of skinning a cat if you get the saying. All right, so here we go. Let's do this 2 ways. Here's option 1. Option 1 is you look at this immediately, you say division. This is the first thing you see, which this is ln of 1 minus ln of square root of e to the 3rd. Perfectly fine. All right, here's the question. What's ln of 1? Well, that is, remember the base is e, so I'll write it as log base e of 1 equals what? So e to what power is 1? Ta-da! Right? Minus ln of square root of e cubed. How do we deal with this? Well, I want this ln, log base e is ln, right, of e to some power would undo each other, right? So can I write all this other nonsense as the power? Answer is yes, you can. If you remember your laws of exponents, which I hope all of you do, this is this. This is turning into a very long video, and I apologize, guys. It gives you 3 halves, right? Square root exponent is 3, so it's 3 over 2. So this is 0 minus. Now finally, the natural log and e undo each other, gives you 3 over 2. So the answer is negative 3 over 2. Easy, right? Let's do this a different way. Here's option 2. And I'm going to use the laws of exponents yet again. You notice I'm referring back to all of our skills with exponents. There's a lot of exponential skills. Let's take this all and write it as an exponent. 1 over e to the 3 over 2. Right? Negative exponents really mean ln of e to the negative 3 over 2. And then finally, the bases are the same, so they undo each other. Notice we got the same answer. Work is absolutely the same. Now, so what is the point in fact here? It comes down to how you see it. Okay, you have to see it. What I mean by you have to see it is you have to understand where some people zoom in on the division sign first. Some people zoom in on this first. Some people zoom in on the fact that the bases are the same first. And depending on what you zoom in on will be your first initial move, which will take you down one of these paths. And moral of the story is, when you start a path, you should be able to finish off the path. So I would encourage you not to fret about it and to push through it. Okay, it'll be okay. All right, since we're on a roll, I'm going to spend the last 5 minutes talking about one last thing. I know. I'm a terrible instructor because I keep giving that one more example. This is why I normally let my class out late, and they drive me crazy when I drive them crazy. Because I'm sure they have classes after mine. So this is a perfect example. Some people see the subtraction sign. Everything here is base 3, though. This is 81. This is 27, right? So I'm going to do it 2 ways, okay, like before. Here's option 1. This is probably the most important example. Yeah, this is a long video, so pause it, go take a pee break, and then come back. Can I say pee on YouTube? I think I can. All right. Anyhow, so subtraction law first. Log base 3 of square root of 27 minus log base 3 of 81 squared. Now, this is a very cool example because it gives you opportunities to use all of your laws of logarithms. Remember, these are logarithms, not exponentials. So in here, what do we know? Well, this square root complicates things. This is 27 to the 1/2. I could parachute that out. Same thing here. I'm already going to go for it because I already see that 3 and 81 carry the same base. I'm going to parachute that out. Now, why am I doing that? It's because I know this is going to simplify. All right, so I'm going to parachute this out. This gives me 1/2 log base 3 of 27. Now, if you're in your head saying, Resh, how do you know things are going to simplify? This goes back to the first couple examples of the video where I'm like, you just got to be good at thinking about them. So if you're not good at thinking about them, go on the internet and search for basic log evaluation problems. So evaluate log problems and just do a ton of them until you just build the mindset of how to evaluate them quickly. So you could just recognize that this is 3 to the 4th power. And you could recognize this is 3 to the 3rd power. Because without that, this is all done. You're just pushing formulas around, and then you really don't even know where it's going to take you. You'll never know when something simplifies. That last step of just to finish the problem, you will always be missing. And this gives you 3 over 2 minus 8. And this will give you, 8 is what? 16 over 2 minus, so that's negative 13 over 2. Did I do that right? I think I did. That's what the answer should be. Okay? That's option 1. Let's look at option 2. So I broke my stylus this morning. I dropped it and I shattered the tip. That's why the writing is more jankier than normal. I already have terrible handwriting. So let's rewrite this problem, but check this out. What I'm going to do is I'm going to take a look at this. Now you notice everything is base 27. Watch this. I'm going to turn, I'm not base 27, base 3. I'm going to turn everything, and I'm really going to capitalize on the fact. And this takes someone who's a master of exponentials. I'm going to write this as 3 to some blob so I can undo it. Here is log base 3. Watch this. This is where it gets cool. I'm going to change all the coloring. Now, this is not more advanced, but it's different, and it's how you see it. Now, I'm really good at computing things, so I tend to always go more towards the computation part, more so than this. I don't like pushing formulas around. I just feel like this is just randomness, okay? But, you know, it all comes down to how you see it. The numerator. I know this is the square root of 3 cubed, and this is 81 is 3 to the 4th power. So this is 3 to the 4th squared. Ew. Look how that's written. Let me get this log stuff out of here. I'm trying to turn it back red. So this is log base 3, and I'm going to go back green so you can see what's happening in the argument. This is going to be 3 to the 3 over 2 over 3 to the 8. Yeah, right. Now, what do we do when we have the same bases? Notice I'm just still simplifying in here. I'm not even doing anything that's log-like. I'm just simplifying to get it all in terms of 1 base 3. Now, will you always be able to do this? No. That's why I said this one takes a higher understanding, because you had to know when you can do it. I knew everything was going to be base 3 to something, right? This one, on the other hand, though, will work for anything. So if this was like a 49 where it just doesn't simplify nicely, because sometimes logs don't simplify nicely, you'd be able to still grind through it. So you might need to go this route. I'm not saying it's or, I'm saying it's and. You must be able to do these both ways. If you could do these both ways, you're good to go. This is 32 minus 8. Okay, and then finally, why did that write lighter? I have no idea. And then finally, now we get log base 3 of 3 to the negative 13 over 2. Anybody want to guess what happens with these two? Yeah. So you notice we got there. It took the same amount of work. This was like information you should have already had before. This is information that is more complicated, I think. But it really comes down to how you see it. All right. So for sure, guys, this is the last example. I'd encourage you to go back, rework the examples, like when they come up, put it on pause, work it, see if you get the same answer that matches the work, either option it went to, okay? And then once again, if you want to go someplace you've never been, you have to do some things you've never done, guys. So push yourself, make yourself uncomfortable, and but no, feel free to send me an email, come to office hours, let me know what's going on, and I'll try to compensate and make things as comfortable for you guys as possible. All right, signing on until next time. Bye-bye.